Okay, let's see, it's automatically started this time.
So was that big rock did they just leave it there? Like it was just sitting there and they just left it?
I wonder if they brought it in.
That's what my husband, you're making sign language up here. I think we were in this actual classroom too. I don't know, but we would always wonder about that rock. If it was here and they just left it or they brought it, you know, how.
It's like
he loves it. He's like, I want a rock like that. Okay.
His pet rock.
Yeah. We have a rock in our yard, but this one is a big gigantic rock.
Okay.
We have two. One's underground and the other one sits on top of it. You got a rock? I want a big rock like that. I said, piece of a mountain? Yeah.
Okay, now let's pull it in. I think I can get closer. This. Probably not going to use a lot of that side.
Because I've done it exactly how it says in the answer sheet to do it, but
yeah. Okay. And we are recording. I got some fresh markers.
And you either got the same answer as I did, but it's not on the answer choices. Unless you're just meaning like it's rounding it to 7.0, but I figured it would be 7.2. Because that's the answer. And here it is 2.
yeah. Okay, so we'll pick the best answer. That would be 7 again.
Okay. Okay, because I was like, what am I supposed to do? I was like, I got the same answer he did.
Yeah,
it's not 121.
That's another place I need to make a correction.
I see you marked out some questions. I think there may have been one other question. I don't think there was, but I'm going to check and see. Because I circled one if I had a question about it.
This is chapter 8.
Because I went through what I do when I'm like doing these, I'll go through, and the ones I know how to do, like right off, don't have to look at the notes, I'll go through and do them real quick. And then I start, I've always started from the back on study guides. So I started from the back and I would look at my notes to make sure I'm doing them right. And then after I was done, I would check the answer.
What number was it?
121. I think that's the only one I had like the main issue with, was 121.
Okay. That needs to be 7.2.
Yeah.
I'll fix that in the next version.
I just called it and I was like, I told my husband, I said, look at this. I said, tell me if I'm missing something. I was like, I know it's fine, but I was like, look at his answer. He was like, you're right. His answer, you know, they match up. You don't have an answer other than the 7.0. I like that you give the study guide with like the answers, because when I was in high school, they just gave you the study guide. Sometimes they didn't even go over it with you. So I like it because after I'm done with it, I can check it and then I can see how you've done it, and it helps me out a lot. Because I'm like, okay, that's what I did wrong. Because there's sometimes I will, with the conversions, I'll add a whole nother step that shouldn't even been there. But other than that, if I would have added that step, I would have been right.
Sometimes you can arrive at the same answers
Really?
with a different method, but at least that gives you one way to do it.
Yeah.
Let me see. I think we're probably only going to use that board anyway. And And I can pick up part of the periodic table too. There you go.
I also like that you give like these at the back of the packets too, like, and even on the tests.
Oh yeah.
In high school, I liked all my teachers, but they didn't do that. You just had to.
You had to memorize it.
Yes.
Yeah.
And I did not, and I mean, I can memorize some, but it has to be the only thing I'm studying to memorize for me to get it. So I'm like.
There are a few things that you just have to memorize, like
Yeah.
symbols.
Yeah.
But
And I mean, so far, I know like oxygen, hydrogen, like just right off the bat, I can tell you. Like just a couple of them I can tell you right off the bat because I've wrote them so many times. And I'm trying to get it, like I'd like to learn, like over a period of time, the whole periodic table, just because I like just knowing stuff.
that's how you learn it.
And
The repetition.
yeah, and I try to fit so much stuff in a day. It just doesn't work out because where we took sign language, we took like one course of sign language, and we're waiting for her to put the second, third, because I think there's 3 of them. And we took the first one, and like I try to fit that in at least every day for like 30 minutes so I can keep it up and memorize it.
Oh
So
yeah.
I'm like, I'm in the medical field. What am I going to do if someone comes in and I don't remember what I'm supposed to say to them or how I communicate?
Yeah. Yeah.
I wish, like, I mean, I told my husband, I said this, I was like, it kind of sounds like I'm looking for attention to, like, say I have a deaf friend, but I wish I did have someone or know someone that was deaf so I could talk to them, like, frequently, like
Yeah.
FaceTime or something to be able to keep up. Like, they have deaf chats around here, like, at different locations, and I'm on the Facebook page that gives you notifications about it, but every time there is one, I'm either in class or at work. So I'm like, what the hell?
Yeah.
But I'm like, I like to learn everything. It's my thing. So I always want to take on too much.
Oh yeah.
Like my dad, even as a kid, he doesn't like to say it because my brother Jimmy, we always say he was the smartest because he did get like, I don't know what they call it, but he went up 2 class grades. I don't know what they call it. He moved both class grades. He took a test to do it.
He skipped.
Yeah.
Yeah, I know it's recording.
Okay. Let's see. This chapter is what's it called? Composition. Chemical composition. Yeah. What are chemicals made of? Calculating percentages, doing comparisons of contents of chemicals between the two, the different chemicals. Calculating molar masses. Lots of conversion factors. Those are going to be with you till you don't take chemistry anymore. Oh, don't take physics either. They're conversion factors too. And then, let's see. We did we do empirical formulas?
Yes, we barely touched on that.
Okay.
Empirical and molecular.
Molecular. We probably want to be sure and get those. There he
Is
is.
your message?
No, my phone's silenced. When class starts, it shuts off.
It's working on a babysitter. Ain't no school.
Been ready for school today. Working on strike.
Oh, I didn't know that.
Yeah, they're on.
Yeah.
If ever that.
Is that the whole state?
Mm-hmm.
Putnam County was the only county that was still having school, but then the bus drivers all went on strike
When did that start?
today. because some bill, the
Omnibus.
yeah, that bill passed and they're striking about it. I don't know anything about it. I just have a lot of.
It was on strike. Was it last year or the year before?
Last year. Last
Why?
year. I think it was at the beginning of the school year last year.
Yeah, I don't know, was it at the beginning or the end of the year? It was on strike.
Oh wow.
Yeah. That was over their insurance.
I think it was the end of the school year because people were wondering how far they will have to go into like the June and all that.
Well, I won't voice my opinion right now because we're being recorded. But I'll be willing to tell you what I think.
I understand.
Okay, so let's see, first of all, if you have any specific problems, so we be sure and get everybody's concerns addressed before I start rambling. Anything in particular giving you trouble?
The conversion factors on this one, I guess.
Okay, you got a specific one you want to do?
I don't. I just remember whenever, especially when we was going over it in class, that was the part I was trying to take more notes on because I was having a hard time.
Oh, something like maybe, well, that's a pretty simple one, number 3. Did that give you any trouble?
Which one is it?
Number 3?
I think my problem was I always put them upside down on certain ones.
Okay.
When I start my conversion factors,
Yeah.
I put them upside down because I'll end up getting some skewed answers, and I'll go back and I'm just like, oh well.
Now, is that from setting up the problem or for punching it into your calculator? Because I know some students put it in the calculator wrong.
Setting it.
Setting it up, okay. Well,
We're gonna need a calculator.
I mean, I'm sure it's
Yeah.
work problems today.
for the test, you don't have to have one today.
I bet my son lost that one I had. It might be at house somewhere. It's lost for now.
I saved the receipt just in case. It was only like $16 calculator, but that's gas.
I think it's about 9. It's like 9th grade. It still works though.
Do you have one in particular that's?
As we work problems and stuff, I'm sure I'll take process.
Well, what about number 9? You've got a 50.3 gram sample of water. The question is, how many molecules of water does that represent? So this is where you're starting from. And you want to end up with the number of molecules.
Is it 6.022 times 10 to the 23rd?
That's one of the conversion factors, yes.
Okay.
But before you can get there, you need a factor that will convert mass to amount, to numbers, right? And that has to be molar mass. So you've got to convert. This tells you where the conversion factor is going to go. This is in the numerator. That has to be in the denominator. And then this in the numerator will give you the numbers of molecules in terms of moles, right? Once you get to this numbers, then you can use the other one. Okay, that's where your Avogadro's number comes in. But this is the one that you'll have to calculate. Know the molar mass of water. Okay, so you need 2 hydrogens, which is 1.01 times 2. 1 oxygen is 16. Right? So that'll be 18.02. And then you check yourself, those will cancel, these will cancel, and this leaves you with the molecules you need. So after this, it's just crunching numbers. You just have to be sure you put it in your calculator correctly. And if I did my math right, that many molecules. And you can estimate to be sure that that's the right answer. If you take 18 and divide it into 50, you're talking about maybe 3, a little less than 3, right? And then 3 times this, 3 times 6 is 18. So 18 times 10 to the 23rd is 1.8 times 10 to the 24th. So we're in the neighborhood. Estimation is a good skill to develop. Because sometimes calculators give you the wrong answer, and sometimes you put the wrong information in, garbage in, garbage out. It's like any computer. Computers don't read your mind. Maybe one day.
How about 71 is about the molecular and empirical formula. And I'm having a little trouble with going from the empirical to the molecular when it comes to fertile. I'm having trouble with it.
Okay. You want to do the whole thing?
Yeah.
Yeah, let's do the whole thing.
Like so far, I'm to the part to where you get where you're trying to get not molecular, empirical. So I tried to finish it, but the answer didn't come out right.
Okay, we'll do the whole thing just in case somebody else has an issue, or you're watching the video later and it'll be a complete discussion of 71. So what are we given?
83.65% of carbon by mass. 71.
71.
And you said assume that it's a 100-gram sample.
Right. Yes, but we've got hydrogen in there too. So how much hydrogen is there?
16.35.
Mm-hmm. If we know you've got carbon and hydrogen and nothing else, all you need to know is one of them.
Okay.
Calculate the other one. It's 100 minus that one.
Yeah.
Gives you this one. Okay.
So now what, will you say that again? How'd you do with the
If you're only given this value, but you're also given that the compound has carbon, hydrogen, and nothing else. So percentages always have to add up to 100. Otherwise, you're missing something. So if carbon and hydrogen are the only two elements, carbon's 83%, then hydrogen has to be the rest, 100 minus 83.65. That's where these numbers come from. And then in order to convert, what's our goal, right? When you're writing a compound, what do these subscripts mean? They mean numbers of molecules, the ratio of the numbers. They're not percentages, and they're not mass, they're numbers. So we have to get the number ratio, which means the mole ratio of each element in the compound. But we can't convert these to moles because percent is a dimensionless number. It has no value. So you have to say, what does percent mean? Percent means parts per 100. And this is mass percent. So that means it's so many grams per 100 grams. Well, if that's true, then all you need to say is, well, let's say the whole sample is 100 grams. If the sample is 100 grams, then that means carbon is this many grams, and hydrogen is this many grams. Now we can roll with it, because we've got a definite mass to deal with. And the ratio is the same. Percentage ratio, mass ratio is the same because The sample size is the same for both of them. So now we convert. We bring Henry Ford on board again. And carbon then would be, remember, we've got to cancel the grams. Right, 1201. And hydrogen is 101.
That's what I was gonna ask you, if you could just take that and divide it into that 3.65 answer.
Yeah. And the reason we divide it in there is because this is in the numerator and that's in the denominator. That's why I set it up this way. You just memorized, oh, you're supposed to divide this into that. So what if you have a brain fart and you do it the wrong way? Well, the rest of your problem is garbage. So that's why I set it up like this every time. Okay, so that was 71. Why don't I? It's always good exercise for me to do these things without looking at the cheat sheet. Because sometimes I catch errors. So 83.65 divided by 12.01 is 6.965. And that's moles of carbon. 16.35 divided by 1.01 is 16. Did I do that right? 12, 6. Yeah, that's right. 16.189. Okay. Now we've got the mole ratio, but it's not going to fit our model because we want whole numbers. So the ratio is valid. What we want is to convert it to some ratio that represents whole numbers. So the simplest way is just to divide everybody through by the same number. So if we divide this one through by 6.965, and this one through by 6.965, we at least get this one a whole number of 1. And then we'll see what this one gives us. 6965. So I get 2.32. Okay? So we're almost there. Now what we have to do is get rid of that fraction. So you need to multiply everything through by the same number that will get rid of that fraction. Well, the fraction is almost a third. So if we multiply by 3, we'll change that third to 1, and then whatever else happens. So if we multiply by 3, this is 3, and this is 7. Now when you get to this point, close counts in hand grenades, horseshoes, atom bombs, and empirical formulas. Right? So if you're really close, that's all that matters, because experimental error is going to creep in there anyway. You just don't want to be way off. But this is close enough to say that the empirical formula now is 3 carbons and 7 hydrogens. Okay? Empirical. The simplest whole number ratio. Next, we want to know what the molecular formula is.
Molecular, you take the empirical mass and the molecular, the mass for it, and you divide them, like
the small into the large.
Okay, that's what I thought, but I couldn't get I was having trouble getting the empirical.
Okay, so the empirical weight is going to be 3 times 12.01 for carbon and 7 times 1.01 for hydrogen. That's 36.03, 7.07. We'll get 43.1 grams per mole of formula unit. Now, the problem gives you the molar mass, which is 83.65. No, that's not it. 86.2. So the molar mass of this one is equal to 86.2. 86.2 grams per mole. So if we were to multiply through here by some whole number, we could convert this one to that one.
Exactly two.
Yeah,
So
2 works. If n equals 2,
C6, H14.
age 14. That's the molecular formula. Now you have to, if you're actually going to do this in the lab, first thing you're going to do is take your compound in there and find out what's in it. Qualitative analysis. So the chemist said, all right, I've only found carbon and hydrogen. That's good. Then you pick the test that will give you one of them. Really doesn't matter which. Do carbon or hydrogen, and then the difference is the rest. Now you've got your percent. Yep.
Which one is the answer? The C3H7 or the C6H14?
Well, let's see what the question is. What is the molecular formula? It's that one. That's the actual formula of the molecule. This is the empirical formula. If you had this one and I asked you for the empirical formula, you would divide through by 2 and find that it's 3,7. Oh, and then after you've got the percent composition, you need another value, this one, that has to be determined some independent way from that. And it depends on the compound as to which one works best.
Okay. How did you know how to time cut them?
This,
Yes.
well, if you can go to the empirical formula by dividing through by 2, you can go from the empirical to the molecular by multiplying by 2. That's what n is. Multiply this times each one of these inside here, and you get that. Now erase it yet? Okay.
You are recording this again, right?
Yes. I'm sure it's recording this time. Actually, this is probably the more important recording to make than the lecture. Okay. You got one?
I was just trying to make sure I know how to do these right.
Okay.
On number 69.
Okay.
I think these ones are a lot of work.
Yes.
Comes to it.
That's why I set up an assembly line.
Yeah.
Then you don't have to think. Once you get one going right, then you do the rest of them exactly the same way. Did you not get the same answer I did?
I did after I went through and I read through my book, but I kept mixing it up somehow. I kept, sometimes the first few times I tried, I got adventures.
Okay.
That's like right now, I can't even remember.
So let's say what are we given? 100, well, no, what's the question? Which of the samples has the least mass of nitrogen? The least mass of nitrogen, right? We're not going to convert to numbers. We're going to keep it mass. So we want the least mass of nitrogen, grams. What do we get? Okay, 100 gram samples of each one of these. So we've got ammonia, nitrous oxide, hydrogen cyanide, dinitrogen tetrahydride. Actually, that's a proper name, but this is really hydrazine. Heard of hydrazine before? The Germans messed with it as a propellant, especially in that little rocket plane they used. They killed a bunch of people using it too. It's extremely hazardous. And nitric acid. Okay, what do we need to know if we've got a 100 gram sample? 100 gram sample of each one. What do we need to know to find out which sample has the least mass of nitrogen? You need to know the percent composition of nitrogen in each sample. And as luck would have it, we've got 100 grams, so we just need to know, we compare grams of nitrogen in each one. All we need to know is the percent composition of nitrogen. There's your answer. Because we've got 100 grams of each one, right? And percent is parts per 100, grams per 100 grams. So we just need to know the percent composition of nitrogen. How do you do the percent composition of any element in a compound? Go over here. This one's going to be
14.01.
right. 3 times 1.01, right? Okay. And we set the rest of them up just like that. So this one will be
2 times 14.01.
right.
All right.
And then you always have to put that one down here too, because it's part of the whole.
Yeah.
And this one is just one of them, plus hydrogen, plus carbon. And then this one is 2 nitrogens again. Plus 4 hydrogens. And then this one is 1 nitrogen again. And then a hydrogen. And then 3 oxygens. There we go. Once we get these answers, all we have to do is compare them. Find out which one's the smallest. So this one turns out to be there we go. So the least is nitric acid. Right here. Why is that one the least? Probably because it's got 3 oxygens. And that makes the denominator huge. That drives the overall percent down.
I don't think this is gonna be as bad as I thought it was gonna be when I first looked at this.
Which one?
When I first looked at the.
Oh, the whole thing?
Yeah, yeah, that's like, oh god.
Yeah.
I swear that reading that stuff on that SIN gauge helps you out so much. It's a lifesaver.
Okay,
Yeah,
good.
each page you do, it makes you a problem at the bottom of it. It
Mhm.
takes you step by step. It teaches you how to do it right.
And if you make a mistake, does it tell you what you did wrong?
Yes.
That's good to know.
And it's right on par with stuff you can tell, see.
That's good to know. Yeah, I don't need to be whispering something in one ear and they're whispering something in the other ear. I bet those shop towels are a lot cheaper than those little eraser things that they
Oh, yeah.
and they work better too. And when you load them up, just throw them in the wash.
Eraser.
Huh?
Can't do that with eraser.
No, you just have to throw the thing away. I mean, temporarily, I can take it and just kind of wipe it across here and let stuff fall on the floor. But no, they're just money makers for somebody. Well, let's see. Do we have any short answers in here? Some of my, no, this one doesn't have any short answers. Let me see if I can find a weird one. $91. Now we give anybody fits.
Those ones actually do, like, let me find the problem that I had left over. I had one that.
Of that type of problem.
Yes. I think it may have been at the very beginning. Yep, number 5.
Okay. Oh, yes. Number 5. That looks like something that I'd give you as a bonus. So let's see if we can figure it out. 5. See, we have a compound that has the formula X2Y. Then we have another one that's X2Y2. Okay? In this one, 60% X. And the question is, what's the percent Y in this one? Okay. Let's see. So let's say we have, well, one thing we can tell from this one is what's left over is 40% Y.
So what would equal 60? Is it 100 grams sample? I guess we
Yes.
assume.
If we assume a 100-gram sample,
So that means
So
60 grams.
assume 100 grams. Then this one's going to be 60 grams of X and 40 grams of Y.
So the X would have to be 30 grams on the periodic table, right? Where it says X2.
Yes.
Okay.
If you've got two X's, then each one is going to be 30 grams per X. So if we take that information and go over here, because one Y weighs 40 and one X weighs 30. So over here we've got percent Y would be, we got two Y's, right? So we got, this is in the bottom, plus what's, and then we have two 30s. So that should be, what, 80 over 80 plus 60 is 140? Is that right? 80, 60, 140. Okay. Cancel those out. So 8 divided by 14 times 100 should give you the percent. 57%. And since it's multiple choice, you look and see which one's closest. Oh, I actually did. I must have corrected that one. I think at one time I had 60% in there. That was the closest you could get. But I went back and changed it for this class to 57. So it would perfectly match. Did you see where that came from?
How did you get? Okay.
This part here.
Yeah, I was just wondering how it was on the.
Okay, so we determined over here the ratio is 40 grams of Y to 60 grams of X, but two X's means that each X is 30 grams.
Never mind. I see what you're doing. Because you're trying to find the percent. So
Yeah, percent
that's how
Y.
you drop 2 times 40 on top and bottom.
Yes,
That's what you
there you go.
Can we do number 11? These ones still get me. After the conversion and everything.
Okay. Let's see, I better erase this before I start.
Let's move another one.
So we have 11. Let's see, what are we given? What's the question? Calculate the mass of sulfur in 1.74 moles of sulfuric acid. Okay. So our starting point is 1.74 moles of sulfuric acid. We want to end up with grams of sulfur. Okay, all right. So before we convert to mass, let's change this one to how many moles of sulfur does that represent? Okay. If we try to do the mass first, then we got to calculate molar mass of sulfuric acid, and that just adds another monster step. So let's convert to how many sulfurs, and then all we have to do is look up sulfur. So if we have sulfuric acid, sulfur, the ratio then is 1 sulfur, right?
Yes.
For every mole of sulfuric acid. Right? So we actually have this many moles of sulfur. Okay. So now that we have the moles of sulfur, then we can say, what's the molar mass of sulfur? 32 is 3207. So that will actually give you the answer. How many grams of sulfur?
Oh, okay.
Now, you could have done it the other way. Change it to mass first. But
I think
then
that's what I was trying to do, and I was confusing myself on.
it adds a lot more steps.
Okay.
Because if you convert to mass first, then you also have to find out what's the percent sulfur by mass. Because once you're in mass, that's the only way you can convert. This kind of reduces the heartache. What was it? 55.8 grams?
Yeah. Sorry, I done it and then I turned my page. I didn't think to say the answer.
Let's see if that estimates right. Yeah, 1 3/4. 1 would be 32, and 3/4 of that would be like 16. Let's say is 24. Yeah. 24 and 33 is about 54.
Can we do another one of the ones with empirical formula and molecular?
Yeah. Is there a monster in here? We need.
I'm not sure. I know 22 is one of them that's asking what its molecular formula is.
Okay.
Then there's 32 that's asking you what the empirical and molecular formula are.
Okay. That one's got carbon, hydrogen, oxygen.
I'm trying to see if
And-
there's any other weird ones.
That would be a good one.
Then there's 63. Yeah.
63.
63. Actually, there's 59 and 63.
Okay.
I think that's all.
Certain compound. Oh, okay. 63 has already taken it part way for you.
Okay.
So let's go back and do 22, is it?
32.
Oh, 32 would be better, yeah. Because it's got 3 elements in it. $32. So you're given the molar mass of the compound right over here. I'm just going to put it off to the side. Okay, we'll use that later. Now we're given 65.45% carbon, and hydrogen is 5.45%, and oxygen is 29.09%. Okay. So it wants both empirical and molecular. So we're going to assume 100 grams. So each one of these implies 65.45 grams, 5.45 grams of hydrogen, and 29.09 grams of oxygen. So now we need to convert to moles so we can get the mole ratio. Okay, so carbon's going to be 12.01, hydrogen's going to be 1.01, and oxygen to be 16. So I get 5.45 moles of carbon, to 6.39. No, that's That's not right. I miscalculated that. Let's try that again. Reason I know is I did an estimate in my head and it just didn't fit. That's better. 5.40 of hydrogen and 1.82 moles of oxygen. So now we have a mole ratio. We just got to convert it to whole numbers. Divide through by the smallest one. So I get 297, 2.97. For that one, and 2.99 for this one. Okay. Now I think we're close enough to 3.
Just round it.
Yeah, just round it to 3 on each one. So that means C3, H3, O1. That's the empirical formula. So we need an empirical weight. So that's 3 times carbon plus 3 times hydrogen plus oxygen. So that's 36.03, 3.03, and 16. So I get 55.1. All right. And since this is the molecular weight, and if we ratio 100 to 55.1, it's about 2, a little less than 2. Let's see, that's 32.
It's like 1.815.
Right. So that means this is going, the molecular formula is going to be C6H6O2.
So it's going to be B.
32B. Yes. And we're pretty sure that's it. That is a lot of error. So you probably want to go back in the lab after you've done this and check yourself again, especially if your job depends on it. And if you do several replicates and they keep coming out like that, then you can do some other tests too. I mean, this is beyond what we're doing here, but you could do, this is an organic compound. You can put it in an infrared spectrometer and get a scan on it and find out what your functional groups are, see if it matches up. You can do, if you've got a really wealthy lab, you might have a mass spec, run it through the mass spec and it'll check it against the library and say, yeah, that's probably it. So you have several avenues of support that you can go to. This might be this is probably a cyclic compound.
See, earlier I was wondering how you do that times that by 2.
It's the ratio of
So you divide 100 by
right.
whatever you get.
ratio of that one to that one in terms of its molar masses. Yeah. Okay, so let's go to, what was the next one we were going to do?
Like 22 or something.
We're going backwards?
I'm there. I remember still saying that. I'm not remember if it's good.
I thought we were going over here to, not that one. Well, maybe, yeah. You might be right. We're going to go backwards. There was another one in there too.
I'm going to 83.
Say again?
83.
83. Okay. That's a challenge. Let's see. All right, clear the board. Okay, so what are we given? So we've got an unknown substance, A. We have 12.6 grams of A. And we're comparing it to 35 grams of chlorine gas. Remember what chlorine gas is? Diatomic. Okay? We also know that substance A, this one, has 5 times as many molecules as the chlorine gas. So this is equal to 5 times the molecules of,
It's 1.5.
I'm sorry?
Is it 1.5?
Yes, 1.5, excuse me. 1.5 times as many molecules in this as this. What's the identity of A? So we want to know what A equals. Okay. So if if we're going to say this has this many 1.5 times as many molecules, then we need to know what we're starting from, right? So how many molecules does this one have? So how many moles of chlorine gas do we actually have? That's 35, 45. Let's see. .9873. Chlorine gas. Okay. So this is going to tell us that how many moles of A we have. Right? Because for every one of those, we have 1.5 times that many. So I get 1.481 moles of A. Okay? You might see a pattern developing. You know how many moles of A you got, right? You know how much that number of moles weighs? What does that tell you? Molar mass.
And he's working night shift, but he's wanting to get a different job to where he can make more money, to where I don't have to work as much, to where I could concentrate more on school.
Okay.
And I'm telling him, you know, I could help him a lot in school. And I was like, just so if like maybe things happen, I was like, what if we had a kid, like an unexpected, you know, child? And so I was like, it'll be rough, it'll be harder. You know? I was like, I think you should just at least start with like 3 classes. I was like, it'll add up.
Yeah.
At least you're just prerequisite classes. I think I almost got talked into it.
What's his hours?
Right now he's night shift, so usually it's 11 to 7, and then he sleeps from 7 to 3. So he only has that time period from like 3 to 11 to go and do stuff.
No, at his job, does he have time to stop and get on the computer or anything?
They won't let him.
Okay.
Like he's taken my computer with him to like use it and look at different jobs and stuff.
Yeah.
But they get on to him, like they'll see him on my computer at his work and they get on to him about it. Even though he's sitting there 11 to 7, you just sit there and do nothing because he's front desk.
I wonder if he went and talked to him and told him that he was trying to further his education, I wonder if they let him.
That's why he's trying to get a different job. I think I have him on my talk to him to just doing like 3 classes. At least next fall, starting 3 classes. And I'm like, yeah, I'll help you. Especially if it's like math or chemistry, I can do that. Which of course he doesn't really know what he needs to go to school for either yet.
I'll tell you what happened to us. We started coming here for the PTA program. Been here for a year
That's
and a half.
what he wanted to do.
And then all of a sudden, they told us
They lost the accreditation.
they lost accreditation, but then Ron was like, no, just stay here. We're going to get it right back. And then it's just like a month ago, he's like, no, listen, we're not getting it back until like 2022 or something like
Yeah.
that. I was like,
Yeah, that's
oh my God.
That's what he wanted to go for, and then I heard about that, and I told him. He said, well, what can I do? I said, you can still get your free requisites. I was like, get them out of the way. I was like, and you'll have them, so if you change your mind and you want to go into radiology or something, you have.
See, that's what I started doing, but the deadlines for everything, I had like 5 days to get into the test and stuff. And luckily, Logan, I had everything I needed to get in Logan. My GPA is a 3.75, so they said I'm good there. My ACT scores was good. So I should get into the Red Tech program there.
Okay.
But I hated having to go all the way to Logan.
Yeah.
It's farther.
It's a drive.
You know?
But it's closer to you than it is to me.
Yeah. It's like an hour and 20 minutes. And this is like an hour and 5 minutes. But sometimes we
It's
make
a
it
long
here.
drive.
Yeah, it's like that. But
I always complain about my drive, and I'm like 15, 20 minutes. I just hate driving is the thing. Like, if I could pay someone to drive me everywhere, I would. I can't stand to drive. I think it's the people. There's a lot of dumb drivers.
Oh, yeah.
oh, yeah, for sure.
No doubt about that. And then it's like at the beginning of every winter, they have to relearn how to drive on slick roads.
Oh, yeah.
Yeah.
I know I drive slow in the winter, but I'm just trying to prepare for if someone hits me or.
Oh, yeah.
I hit ice, at least I ain't going like 60 miles per hour. Like, I will go 25 if I'm like not wanting to hit ice and not wanting to slide.
Let me tell you, 2013, I got hit 3 times. 3 times I got hit. Twice by drunk drivers, and once when I was a security guard sleeping on the side of the road in Yager, a coal truck guy went to sleep and veered off the road and hit me. And it cut my Ford Explorer open like a can opener. And luckily I was laying against the door asleep like this, and it came through and cut my seat, my passenger side seat in half and everything, and clipped the side of my seat. If I'd have been laying like regular, like you said, with the car right here for myself. Imagine being dead asleep and something. You get waking you up.
Yeah. Okay, so
63.
63.
Is
Okay.
that the one? Yeah.
60.
Or, no, we already talked about 63.
We can do 63 again since it wasn't recorded.
Okay.
So here it is. 63. So you're given the empirical formula of NH2O, and you also know that the molecular weight, or the molar mass of the molecular formula is between 55 and 65 grams per mole. So since you're already given the empirical formula, we can calculate the empirical weight, which would be 14 plus 2 times 1.01 plus 16. Okay. So that should be, just calculate it. And 16. So I get 3203.
And you said that to do that, you'd start multiplying it by 1, 2,
Right.
just to see what you get
Because-
between 55 to 65.
What you want is the n,
Yeah.
and if n is equal to 1, then the value is 32.03,
That's the left.
and that's not in that range. But if n equals 2, it's 64.06, which is right there.
So it would be N2H4O2.
Right. N2 H4O2 would be the formula.
That it just confused. I was like, how in the world did he get 2?
Maybe I need to.
I mean, in a
I need to
sense,
modify
it explains it, but I was just very confused because it said NH2OX and it says is X equals 2, and I was like,
Oh, if. I'm
oh,
sorry.
that's if? I
Yeah,
thought
if.
it said is. It
Yeah,
is.
That's my F's.
Okay.
I just do that for my F's.
Okay.
And when
I
they're
think that's what confused me.
written small like that, it looks like an S.
Number 60, the number of moles in the barium phosphate. Phosphate is back here on
The ionic,
atomic
the,
outline.
yeah,
Now, what do you have the barium?
it's BA.
BA.
56.
So it's asking you the molar mass for that one?
Or number of moles.
The number of moles, 359.7 grams. 359.7 grams of barium phosphate.
BA3.
Ba, and then you have phosphate, which is that, and it's a 3 minus, barium
Phosphate's
is
a 2.
2 plus,
Yeah.
right?
Yeah.
Because barium is right here in that family, so it's 2 plus charge. So you bring 3 here, and 2 there. Now you have your formula.
Calculate the.
So you do 3 times 137.33 for barium, and then 2 phosphoruses, 30.97, and 8 oxygens. So I get 601.93 grams per mole. And then I always have to go back to the question. Number of moles of this compound. So all you have to do is convert that to moles.
Do they still say something? I don't even want to track it down. I just saw the commercial.
So if you write it this way, that means this has to go on the bottom because that's grams. So you divide this by that number, 359.7 is 0.597. Or 598. Yeah, 598. I didn't round it properly. There we go. So the real stumbling block in this one is going to be writing the formula correctly.
But all we have to do is go back and look at your polyatomic islands that you want to have on there and plus know what barium is.
Right. Know where to find barium.
Okay, I have a question. Ken, you have me on 52.
Okay. 52.
What about grams to atoms?
Okay. So 52 says 66.4 grams of platinum is how many atoms? Four grams of platinum. Okay. So in this case, I would look at the answers to say, okay, we do need actual numbers of atoms. Because sometimes they'll say how many atoms, but they'll give it in terms of moles. In this case, yeah, you do need to convert to moles and then to atoms. So platinum is right over here.
195.
Oh, wait. Okay. That gets rid of the grams, leaves moles, and then we convert moles to atoms.
So anytime that asks for atoms, we gotta use the 6.022 times 10 to the 3rd.
If I would look at the multiple choice answers and see what the units are. Are they actual atoms? In this case, they are. Then you would have to use Avogadro's number. Sometimes the answer is in terms of moles. If it is, you don't have to go that far. So I get 2.05, since that's 5 significant figures, times 10 to the 23rd atoms. Yep. The answer is there. Letter C. Oh, I see why I threw that one out. We're not dealing with ions yet, are we? Number 42. Really, it's simple. You just have to bust your molecule up into separate ions for 42. We'll get to that one. I need to be the next chapter.
Okay, on number 51. I'm pretty sure on how to do this. I just want to check, okay?
Okay. So we're gonna 51.
Mm-hmm.
I'll let you tell me what to do. What are we starting with?
460.2 grams
Of
what's it again?
magnesium.
Magnesium and CO2. Is that chlorine?
Chloride.
Chloride.
Okay. So that's what we're given. And it's asking for how many molecules that is.
Mm-hmm.
All right. So this is a conversion factor problem. We got to go from mass to numbers. And the first step is mass to moles. Then you can convert to molecules. All right. So you just have to get the molar mass, 24.31 for magnesium, and then 2 times chlorine. Whatever that happens to be. $95.21. And this is about 100, so that ought to be maybe 4.5, 4.7 maybe, and then 4.20, maybe 30. So it ought to be in the neighborhood of 3 times 10 to the 24th. Pretty close, 2.911. So I estimated it 3 times 10 to the 24th, but it's actually 2.911 times 10 to the 24th. You get the same thing?
Times the 460.2 times 6.022 makes sure I did that right.
Okay, you did this times that,
Yes.
and then divided by that.
Yes.
You should get the same number. Yep.
Equals 2,770.12 divided by 95.2 and it's saying 29.9.
Times. Oh, you didn't put the exponent in there? Okay. You left the exponent out, didn't you?
Yes.
Okay. So you're going to have
I
what?
just have to go over one.
Right,
and add that to 23, right?
right.
Okay. So if the answer don't come out with the same, with like a 2 point something, or you have to move it over.
Yes.
And how many every time you go over to the 23. Okay. Yeah, that's where I messed up at.
Oh, using the phone calculator, it doesn't do exponent stuff. Okay.
I have a good calculator. My son's been playing with it. It's probably in their couch somewhere.
This is just information on, look at 48 on
Oh, my answers.
your answer sheet.
Okay.
And then 48 on the test, I calculated it how, like my formula is actually how you have it. And I calculated it, and on your thing it says 1.20 times 10 to the negative third. And I got 2.20 times 10.
Oh, that's a 2.
Oh, that's a 2? It
Yeah,
looks like a 1.
sorry.
That's okay. Number 48. Okay, I'll just make sure. I was like, that's a 1. But okay, let me make it a 2 on here.
That's good.
I can see how it looks like a 2.
Yeah, check on it.
But I was like,
I have made mistakes before.
I just hate, like, I've always been, like, wanted, like, told teachers of problems I've found, and sometimes I've been wrong, sometimes I've been right, but I hate doing it, because I'm like, I feel like I'm contradicting them.
Oh,
But I
no.
know some teachers appreciate it, but I've had some that did not like me doing it. But I did
Yeah.
it, so I was like, I'm iffy about this.
No,
That's right.
I think about the consequences. If I give
I
you,
do it all the time, and like, have you ever read a book and seen errors in a book, like reading? I do it all the
Yeah.
time, and I'm like, I'm always showing that.
this thing was actually proofread before they published it.
Really?
Yeah, you know what? Your editors.
Yeah.
You know, where did your editor go to school?
Uh-huh.
You know, Walmart.
I'm always like, it's usually every other book I read, but there's usually one error I'll find. I'm like,
That
get some money for finding this.
Yeah, the news outlets, whether they're printed or broadcast,
Mm-hmm.
they're notorious for grammatical errors. There are 3 or 4 of them that are just they make my teeth grind when I hear
Yeah.
them. And then, of course, if you're on social media, especially Twitter,
Mm-hmm.
oh God. When I feel like I want to tweak somebody's nose, I just go on Twitter
Oh,
and
yeah.
read some of them and respond and tell them where they're wrong.
On number 49.
49.
Yeah, see, I thought that you would take the 35.45 and you have to times it by 2 because there's 2 40s. But I guess.
In this case, we're using 3545 per atom.
Okay,
And the conversion right next to it.
it has the 2.
Right. Now, your way would work, you could combine those 2 conversion factors into the 70 atomic mass units per molecule and just do it all in one conversion. That would work. That would be just fine. No problem. Yeah. It's like I was saying earlier, you can, very often there's more than one way to solve a problem.
Okay.
Yeah. I still know him. He's retired now, chemistry teacher at Concord.
Mm-hmm.
John Elkins. He had this one student who actually came to work with us for a short time over at the USDA lab when I was there. And he said he doesn't know how this guy would solve problems in his class. He'd get the right answers, but he just couldn't follow his work. He'd always get the right answer. But it just is just the way his mind worked. It just did not compute. So he eventually decided just to give him credit for it and go on.
Yeah. 45. It says how many molecules of O2 are there and 2.2 moles of O2. These kill me. I never get the conversion factors right.
40.
Usually I'm mix them up.
Okay.
45. I think I narrowed it wrong. I think I put 2.2 mole multiplied by 1 mole of O2 over 6.02 of Avogadro's number, and I think it's supposed to be switched around, right?
Let's see, if we're starting off with 2.2 moles of oxygen,
Yeah, O2.
and how many molecules of O2 are there? Well, the mole doesn't care whether it's oxygen or what it is.
Yeah.
You know, it's just this,
Oh, that's what I did wrong.
right? You don't have to be concerned with that too.
So you don't have to take in times 2 oxygen.
Okay. If you were going to do how many atoms, yeah.
Okay.
But molecules, no, that's it,
I flipped them. I had Avogadro's number on the bottom.
right? If I said we had 2.2 moles of chickens, you just say that per mole of chicken. There you go. You have that many chickens. You wouldn't have a chicken wings or chicken legs. You'd have whole chickens.
I just hit a date. What number was that again?
45.
Well,
So the danger has to be D into 6 is close to 12. I don't think what's going on there 14.
1120. Huh?
Is the answer D mean E
For
number 45? 2 times.
D, yeah, 1.3 times 10 to the 24th.
Okay, I got this wrong now. Was the 6.022 on top or bottom?
Top.
I put it on the, when I first done it, I put that one. I think I put it on the bottom. Yeah, that's how I messed up, is I put 1 mole on the top and then I've got it on the bottom.
Yeah, you always have to ask yourself,
I forgot to move it over again.
are the units going to cancel? If you put it on the bottom, then the units don't cancel.
Yeah, I put, for some reason, I put Avogadro's number and I put mole out beside it. Then I looked at it and I said, I see why I messed that up now. When you started explaining, I was like, that's what I did. That was on me.
Okay. We'll see you in a couple of days.
Do you want to have any bonus questions?
Let me see. Yeah.
Probably that big old one.
Yeah.
There's 45 basis and 18 bonus. Let's see, actual problems, 1, 2, 3. 3 actual bonus problems. So there are multiple points per problem.
Is it going to be on the stuff we're studying on, or do we need to study something different?
No, we covered everything.
Okay.
Yeah.
I hope you're not that kind of teacher. I like it. I don't want to not like it. I had a couple teachers get it. They would put stuff on there that we didn't go over, and I was like, I guess this is time for my
Now,
gut feeling if it's right or not.
you are reading, I know you're reading the chapter because you're doing the homework. So I have students that, they just take the PowerPoints, that's it.
I review my
Or they
notes.
might take the PowerPoints and the reviews, and that's it. They don't read the chapter.
I sit at home and
Not a
I'll
good
have
idea.
my notes that I wrote down, the PowerPoint, and then I'll have a book open, and I'll have the study guide.